Welcome everyone. We're doing some work out of the textbook and we're doing a new unit on statistics, and we're going to be drawing graphs. We're going to be summarizing the data, and I find this kind of work enjoyable. There's always a story to tell, and we've got to get good at interpreting what it all means. So we're going to start off just thinking about the different types of data that we're collecting, and whether it's first-hand data or second-hand data and things like that. And there's a few words that we need to know about. For example, the difference between continuous data and discrete data, and things like that. So they're all things I'm thinking about as I'm doing this work. And the other things I often think about is, once I've got the data, I'm always thinking about how large the data set is. And fortunately for you guys, the data sets that you're working with might only be, 5, 6, maybe 10 numbers, just to help you get a sense of what's going on. So I'll just encourage you, the first thing that you do is, when you look at a set of data, ask yourself, is that list an ordered list? Like, does it start off with the lowest number and are they all in ascending order until the highest number? And if they're not, quickly rewrite that list and put them in ascending order, because the things that I'm talking about next are often easy to see when you've got an ordered list, and there's not a lot of work to do apart from that. So when you've got an ordered list, it's quite easy to see the range. So the range, if you wanted to calculate it, it's going to be the highest value, subtract the lowest value. When you've got the ordered list, it's easy to see. So we're kind of just trying to work out where the numbers are spread in between the lowest point and the highest point. Where are all those values? And we kind of expect, and one of the underlying assumptions of statistics is that most of it will be in the middle somewhere. So we need some words to help us describe the middle of a set of data. And we've got 3 words, all starting with M, and they all mean something slightly different. They look the same, basically, but we need to understand what the 3 words are. So I've got them written down on the card here, and the first one I want to talk about is the mean. All right, so there's my face, mean. Now, it doesn't mean that. What it actually means is, it's just a fancy word for saying this, the average. And to calculate the average, we'd just add all those numbers up and then divide it by the number of data points that we have. So I think we understand how to work out an average, and what we say in statistics is the mean. Okay, now I'll put those words on either side of the card, so hopefully you can see, you can talk about them that way, but what you'll be presented with is this word here, the mean. Now there's another word here called the median, and it's a measure of the middle as well. And it's a little bit different from the average. Okay, so when you put your data set in order, you can step in with your fingers from either end and just cover up one data point at a time from either end, and you will meet in the middle. Okay, so the median is a measure of the middle value. So how I think about it is like this: like, I've got 2 lanes of traffic here, and often there's a strip in the middle, and it might have trees in it, or it might have fences on it. to separate the two opposing lanes of traffic, and that is called the median strip because it is in the middle. So we've got mean and median as measures of the middle, and we've got one more to work out here, and that is the mode. And that's probably the least frequently used measure of the middle. But it's really useful in some situations, really specific situations. And what does the mode mean on the back of this card? See how the mode, MO, the most common. See how I've underlined those things? So the mode is the most common value. So you look in your ordered list, and if there's a whole bunch of 2s in your list, and that is the most frequently occurring number and the most common number that you see, well, that is your mode. All right. So what should happen in a really nice data set? We've got the range at either end, the highest and the lowest, they're there, and we've got most of the data points in the middle here. And if everything's perfect, the mean lines up exactly with the median, and it lines up exactly with the mode. Now, that's a perfect world. But in reality, they could be in slightly different positions. All right, if you had to plot them out and say where they could be in different positions. Okay, and the mode, remember we don't use this one very often. It could be anywhere along here, usually in here somewhere. Okay, so that's done there. But mostly we want these two guys lining up. Okay, if our data is really skewed out one end, way out there somewhere, that might drag the mean one way, might drag it out here. So in some instances, we're better off reporting the median value rather than the mean, because some extreme values, remember we're calculating an average here, we've got to add them all up. Add them all up. So if we've got some really large values, they're going to drag this guy off the screen and out the other side here. So we might be better using this. And they're all judgments that we need to make somewhere along the line. But the first step is just to being able to know the difference between these three things. So I'll just jump on the light board and show you a few moves here. Thanks. Now we're doing an introduction to statistics, and there's a few new words here that we have to know, and it's just I think about it as just being the probably the worst part of this unit is the words. But once you take the time to understand what I'm going to say here, it's kind of simple. Everything else is pretty easy to understand. So don't let the words trip you up. So we say data, or if it's singular, we might say datum. But most of the time, it's data, okay? Because there's plenty of information that, and hopefully when you're doing statistics, you're collecting a lot of information. You're getting a random sample of the population, really, and we'll talk about that in a minute. But this information, we've got to think about what it is, and if it's a quantitative measurement, I see the word quantity in here, okay? Quantity, okay. And so that helps me understand what type of data it is. If you've got a quantity, you're measuring something. Now, we break that down into two sort of subcategories. And we call it discrete data, discrete numerical data, or discrete quantitative data. You might see those words being used. But this is like the whole numbers. And think about some of the questions that you ask when you collect this data. People don't have 1.5 cars. They don't have 1.5 pets. And they don't have 1.5 children. So the answers that you get will be whole numbers. So that will be 1, it could be 0 actually, 0, 1, 2, and so on. Okay? And then you've got to understand that if you are using fractions, for example, you're measuring something, and it might be height. So these quantities, we've got height, we've got weight. I'm just going to short that to WT for weight, and temperature are good examples of this, where it's continuous data. So we could have a measurement of 172.0 centimeters. We could have a measurement of 172.25 centimeters. If our measuring equipment is accurate enough, we could include a few more decimal places. Okay, so the answers we get, and the clear sign here is it's obviously point something. So you might get measurements like 80 kilos, and then you might get a measurement of 81.5. And so we're measuring along a continuum of values, and so that's different from discrete quantitative data, okay? So the other thing to think about here, and the word is buried in it again, if you look here, it'll help you make these decisions. I see quality. Okay, in qualitative data, we're looking for, I don't know, I think about names as a good example of this, because we're naming something. If you're asking people what their favourite colour is, for example, so colour is just a name. We've all agreed what red looks like to some degree. Now artists might argue about the different shades of red or other colours, but we've got a name for these things. Even the shades of red might be crimson, scarlet, or something. Okay, it might be a brand. Okay, a particular brand that we're asking people what's their favourite brand. It could be things like preference. Okay, and we might say things, agenda's a good one too, because they're all names and they're all descriptions of things, and we put them into categories, and that's why it's called categorical data. So far we've done a lot of talking just about the different types of data, and unfortunately we're not quite done. So we're going to think about how we collect the data, and we have like primary, and I've used this symbol here. That symbol means primary sources. So imagine you're the scientist, or you're the mathematician, or the engineer or something, going out asking the questions, taking the measurements and collecting the data. You've done that, and so you've scribbled all down the numbers, or put it all in a spreadsheet, and so you've asked the questions and you've collected the data. So that's primary data, because you've been involved in the collection of that data. And we've just got to be really careful. I'm going to use this symbol here. It's 2 prime, or secondary. We call it secondary data, or sources. Okay, you might be looking at data that someone else has collected and published, and you might be looking at maybe a combination of 20 or 30 different studies and seeing if they're all similar. Okay, they're things, I see them mentioned in your textbook, but for us, they're sort of like the little nuances, and I guess, what are they? They're just the nice to know things about statistics. What's more important that you know is this big idea here, or the key idea that I'm going to explain to you now. And that is, when you're doing a survey, you might think I've got to measure and sample everyone and ask everyone the same questions and all that kind of thing. So I've used two words there, and one of those is sample, and the other word is population. That's everyone, the population. But what we do, and this is a really neat thing about statistics, is that we just take a subset of the population. And if we do this well, we get some information that we can generalize to the entire population. So if you take a random sample, and this is important, a random sample. So you've got to, I don't know, what do you got to do? You can't go and ask all the same people from the same workplace or the same business or the same town or something. When you do surveys, you want to get a cross section of the population. So you need to randomize that in some way, and there's ways to do that, but we won't stop and discuss that right now. But I think it's important for you to know that if you take a random sample of the population, and you've done that job properly, then you can, the data that you get is representative of the population. So that's a really cool thing about statistics, and once we know and understand that, it makes our job a lot better. But the key word here, and I've double underlined it, and I might circle it now, is that we need this to be a random process for this to be true, and that's one of the key critical things. Now I'm going to clean the board, and I'm going to get into some other things that we need to know. Now we're back, and I've cleaned the board, and I've rewritten the key points here in blue, and I'm always thinking about this kind of stuff, quantitative versus qualitative data, and what little subcategory that it fits into, right? And the other big key idea here is that we've got a sample, which is just a subset of the population. If we do the job well, it's a random sample. Okay, in pink down here, we've got some new words, and they all start with M, and they're all measures of the middle. So there's a fourth word, measures of the middle, and they're mode, median, and mean. So the mode is I think I explained, it has its place and it has its uses, but we report it, and it is a measure of the middle, and you'll be asked to calculate it, and it's not difficult to calculate. The median is not difficult to calculate, and the only one that's requires a bit of effort really is the mean, which is just the sum of, and that's what that symbol means that I circled there, sum of the data divided by the number of data points. So let's see how that plays out, and I'll walk you through this set of numbers here. So if we had to think about what these numbers are, well, if they're measurements, they would be some sort of discrete quantitative data. And what I look at first off is the first question I ask myself is the list ordered? Okay, and that's really important. So I think one of the first jobs we need to do here is put it in ascending order from smallest number to largest. And That's really useful, and that's the best way to work. So if you see these lists in your textbook and you've got to transfer this information into your page, the really smart move is to do this directly from the page rather than write it out twice. And the other smart move is once you use a number and write it down, put a little cross through it. So what do I see here? I see two 18s, and so I write them down, come up to my original list and cross them off. I see a 31, so I'm going to write that down. I'm going to cross it off. My next number is in ascending order is 54, cross it off. 63, got that there. And then finally, I'm going to write it down and then cross it off, 97. So one of the first jobs is the number of data points. We need a little count for that. And hey, this is really simple. Let's call it n equals something and count them up. We've got how many data points? 1, 2, 3, 4, 5, 6, 7. And I'll just go back to my original list and do the double checking because it's important that I don't miss anything. 1, 2, 3, 4, 5, 6, 7. So we've got 7 bits of data here. Now we've got them in ascending order. I can look, the most frequently occurring number here is 18. So my mode is 18. How easy was that to calculate? Now we need the median, which is in the middle, and that's kind of easy too. If I've got 7 data points, well, if I use my fingers, and this is really hard to see, but I'm going to say to you, with your fingers, count into the middle. And where your fingers meet in the middle, it should be in this number here, 31. So I'm just going to put a line through there to represent the middle of the data. So the median value in this set of data is 31. I've got it. That's all the work I needed to do to work this out. And now there's another really easy statistic to calculate, and this is the range. So that's going to be the maximum value subtract the minimum value. And for us, that's going to be 97 subtract 6. So the range is 91. Okay, we've got all these little summary, they're called summary statistics, and they're summarizing the data in some way. And now we need to calculate the mean. And that's probably the only difficult calculation that you need to do. So we're going to write the mean down, and that's equal to the sum of all the data divided by n. And we've already done that job because n's there. So what does that look like? It looks like, I'm going to write this out the long way one time. All right, so just to show you what it looks like. The sum of the data means adding them all up. So 6 plus 18 plus another 18 plus 31 plus 54 plus 63 plus 97. And we had n, which is the value of 7. We've got 7 data points there. So I'm hoping when I add all these guys up, it's going to be really neat because I want a number that I can divide by 7 here, and that will make this calculation a little bit easier for me. Okay, so what's that going to look like? Let's add them up. I might change the color of my pen here. So I'm going to add those two together, and 97 plus 63 is 160. These guys here, what have I got? I've got 85, and these two is 36 plus 6. I'm going to change all this to 42. So what does that look like? I'm nearly there. I'm going to do this 160 plus 42 plus 85, and I'm at 200 287. And this looks good, right? This is going to be divisible by 7. So here's my next line of my calculation. And I'm going to do this as 28. How many 7s? That's 4 or 40, because we could think about that as 280. And 7, how many 7s is 1? So my mean is 41. Okay, and that's a little bit different, because where's 41? 41's in here somewhere. So the mean is equal to 41. And so that's the average value of the data set, right? And we get that by adding them all together and then dividing by the number of data points. So there's a little bit of work there that needs to be done. But I think that's a job you can do on your calculator too, to help you out with the calculations, okay? Because you've got to be really careful to add things up, and one little mistake in adding all those numbers up and you suddenly got the wrong answer. So I really think it's a calculator job most of the time. So I've just done that in my head there for you, and I hope that it's not wrong. I think it's right. So I'm going to clean the board, and I've got one more thing to show you. I've got 2 questions here just to finish off, and they're in your textbook, so I haven't written them out exactly as I see them in the textbook. So I just want to explain this. We've got playing a certain number of tennis matches, and where there's one of the players is recording the number of aces that they get. So what does that mean if you don't play tennis? When they serve it, it goes into the ball goes into the service box, and the opponent does not get the return the serve or get their racket onto the balls. So it seems like this guy's a good tennis player, and he's getting some aces here. So it's all set out in the table. I pulled it out into an ordered list, and I just want to reinforce a few ideas. And I'm wondering how many matches he played, because I'm counting up the data points here. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 of them. So the middle, if we counted it in, is going to be halfway between the 4th data point in this ordered list and the 5th. So can you see how I put the little dash line down there? Because in the middle between those 2 numbers there is 17.5. So we know a couple of things. We know the median is equal to 17.5 straight up. Now, while I'm thinking here, I'm going to grab the mode, because that's easy. Because what do I see? I see 2 11s as the most commonly occurring number here. So I've got that pretty easy. And I also get the range here pretty easy, because that's going to be the maximum value, which is 23, subtract the minimum value, which is 11, and that is equal to 12. So the range of the values is 12 from highest to lowest. Okay, so there's another stat for you. And we're calculating the mean now. And what are we going to do? We know we need to take the sum of all the data divided by the number of data points. So we've got something here already where we know that we've got 8 data points. So we've got our denominator pretty quickly here. So why don't I just add these 2 guys here, because that's 40, and this guy here, if I make that 22 and that 20, I've got 42, so that's 82. And on this side, I've got 10, 20, 30, 40, 50, because I've got the 7, 2 and the 1. I'm at 51 here. So what's that look like? Let's slot this in as 51 plus a 82. And we're going to divide this by 8. So I've got... Look, the next thing I could do, right, is add those two together. I get a 3 and that's 133 and divide that by 8. I can do that, but I see a little chance here to, let's make this 80 because that's nice and neat, and transfer this over here. I was going to call it 53, but I don't want to. I'll call it 48 plus 5, and that's the same thing. Okay, I'll put a little plus sign here because look what I can do now. I've got 8 goes into 48 6 times, 8 goes into 80 10 times, so I'm at 16 remainder 5. Or I can write this as 16 and 5/8, or I can convert it to a decimal and that would look like 16.625. I think that's got a little bit scribbly there, but can you see what I'm doing there as I'm doing this calculation mentally? But like if you need to, you want to just jump on the calculator and do those calculations. So the next example I've got for you is a really, I think it lends itself to putting on a calculator because it gets a bit tricky. So we're still playing tennis, and now we're thinking about double faults. So the server either gets it over the net and doesn't get it into the service box, or the ball hits a net, and that happens twice. In tennis, you get two goes at that. So we've got the double faults in a table, and then we've got the number of matches that occurred, right? So we could play a match and we could get 0 faults, we could get 1 double fault, 2 double fault, 3 and maybe 4 double faults. We could get more, but hopefully we understand that every time we get a double fault, we're kind of conceding a point to our opponent, and we don't really want that to happen. So these numbers are small, and that's nice. Okay, so that's in the table, and there's some things you can do now to help yourself summarize the stats. So let's do the easy ones, and we've got the range. The range is probably the easiest one. We've got 4 subtract 0, so the range is 4. The number, the mode, that's probably the next easiest thing to grab, because on 4 occasions, on 4 matches, there was 3 double faults occurred. So the mode is 3 because we're talking about the number of double faults and not the number of matches that had occurred. So that's really important. So that, I'll put a little star next to that because that's a bit of a thinking one. So let's calculate the number of matches this guy's played. We need to add these things up. 2 plus 3 is 5, plus 1 is 6, 10 and 12. So we've played 12 matches. So the median has to be, we've got an even number here. Okay, so the median has to be between the 6th value and the 7th value. So that's easy enough to do. There's 2, there's 5 matches, there's a 6th. And so the median has to be in the middle here. And remember, we're talking about the number of double faults here. So the median number of double faults per match is 2.5. Okay, so we're left with one calculation here, which is probably the big scary calculation, because we need to work out the mean. And we know that that's going to be divided by 12. But there's a little trick here, because out of the table we need to say things like, well, there's 2 matches with no faults, so that goes to 0, plus 3 matches with 1 fault, plus 1 match with 2 faults, plus 4 matches with 3 faults times 3. And I'm kind of running out of room here because we've got to drag down this information into our calculation as well. I'm just going to sit it up there. What do we got? We've got 2 matches with 4 double faults. So this looks a bit different for the calculation of the mean, and sometimes depending on how the data is delivered to us, especially in a table, just got to be careful, right? So 3, I'm going to tidy this up as 3 plus 2 plus 12 plus 8. So over 12, and that's looking like, finally, over here, 25 over 12. And that is the mean. I'm going to leave it as a fraction because we've got roughly 2 and 1/12 here. So approximately 2 double faults per match. Okay, is a way to interpret these statistics. So I like that question at the end. That's a difficult one. That's a challenging one. When you calculate the mean, you can jump on your calculator and punch all that stuff in and make sure it's right. You can do it by hand if you want. But the key to it all is understanding how this table's laid out, and that's a little bit different to what you've done in the previous example when we looked at the ACEs. Okay, thank you.